Coral reefs are recognised as a fragile ecosystem with many factors jeopardising them across the world, which have the potential to impede on the well-balanced equilibrium of the system. Of these factors, the algae is of specific importance to the scientific community due to the sizable risk presented. A study was conducted on a region of coral in the Caribbean in which parrotfish and sea urchins were tested in the efficiency of minimising algae growth in and around the coral. It was found that the sea urchins were very effective at grazing algae, and when the sea urchins were presented in large numbers, the algae was controlled, allowing the coral ecosystem to be stable. In the 1980s, there was a sea urchin population experiencing considerable die-off as a result of an epidemic disease. It is believed that this was most likely caused by human-induced global warming. The consequential decline in sea urchin numbers led to an increase in algae growth, allowing the algae to overpower the ecosystem. The parrotfish was also recognised as a contributor to the reduction of algae on the reef. Although as the population of people on the mainland grew, so did the overfishing of the parrotfish. By 1993, the reef had been reduced to less than 5% of its original distribution. Not only did the algae present a severe problem to the reef, natural hurricanes also threatened the reef, being the cause of the eradication of 2 coral species.
This is the author's graph I'm talking about.
The author thought a unique graph. The author's new graph presented on the screen presented the relationship between the flourishing of the coral and the relative parrotfish sea urchin and the algae populations visible. The top of the graph shows the healthy state of the ecosystem, with the parrotfish and sea urchin working harmoniously to keep the ecosystem stable. With the overfishing of the parrotfish, the sea urchins cannot keep up with the algae outburst, and the reef turns to a macroalgae state, which then falls down to the sea urchin die-off, and as a result of the reef dies, and the coral is then rock, and no longer healthy coral reef, which can not be recovered. 3 systems were implemented in order to understand changes in the coral reef. First, a system could have been an equilibrium that is dominant by coral and its associated biodiversity, that is the parrotfish and the sea urchins, and restored to their normal numbers. Second is that because of the human contact and hurricanes, that the system cannot be changed out of the algae stage and back to the coral state. The final system could exhibit alternative stable equilibrium once an ecosystem reaches a stable state, and it does not move out of an alternative state unless heavily disturbed. In all, the results show strong evidence for alternative stable equilibrium and the rapid shifting between the 2 states if significant disturbance occurred. The ability of both sea urchins and parrotfish to keep algae at bay throughout grazing was critical to the final outcome. The authors concluded that macroalgae became more dominant. Grazing by the sea urchins and the parrotfish would have been exceptionally strong to return the reef to its original state of coral dominance. In other words, the presence of these 2 important herbivores is vital for the recovery of the reef. This journal is listed one at a time, with the results being concluded that the reef is slowly dying off because of the algae outbreaks, and the parrotfish and sea urchins